All right, we're gonna walk through exponential growth and decay today. They're basically the same, just one minor difference you can see in the formulas on the front and the back. But really this one is calculator problems. The goal is, can you figure out where each of the pieces of information go, plug it into your calculator and get a final answer. So the formula is written for us. Y equals A parentheses 1 plus R to the power of T. This is for exponential growth. On the backside, you'll see exponential decay. The formula looks exactly the same except minus R. So the only difference is whether you're adding or subtracting R. Everything else stays the same. Now let's give some context to each of these variables. A would be your starting amount. R is your percentage rate, and we need to write that as a decimal. So we'll say percent rate as decimal. And then T is your time. So this has a lot to do with like interest and earning money or losing money, and time could be every month or every year or whatever it happens to be. But one of the key details we just talked about is, hey, we need to be able to write R as a decimal. If it's a percentage rate, we've got to write it as a decimal. The way we convert percentages to decimals is 2 decimal places. So we'll just put a couple examples over here. If you had like 15%, that would be 0.15. See how there's 2 decimal places, 1 and 5 are both decimal points now. If you had something like 3%, this is usually where mistakes might happen. We don't just write it as 0.3, it's 0.03. That's it. So every time we do our decimals, we make sure that we have 2 decimal places, either both the numbers of our percentage or a 0 and then our number if it was a single digit. We're gonna do 2 questions on the front and then 2 questions on the back, but that top notes is the same front and back. First question says, the original value of an investment is $1,400 and the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. So what we'll do is figure out what was our starting amount. A equals 1,400. What was my rate? How quickly was it changing? That would be our increases by 9%. So rate equals, remember we're gonna write it as a decimal, 0.09. And then what's my time? Since it says 25 years, we will put T as 25. So when we set up the equation over on the other side, all we have to do is take these 3 pieces of information, A, R, and T, and put them in their spots. Y equals 1,400 times 1 plus 0.09 to the 25th. And again, this is where we can just plug it into a calculator and get an answer. I need a calculator. All right. Make sure we can see that. 1,400 parentheses 1 plus 0.09. Close my parentheses. This button above division will give me my exponents. I want it to be 25. Y equals 12,072.25. 0.31. Just give me 2 decimal places, should be good. That's it. We can go on to the next problem now. The cost of tuition at a college is $12,000 and is increasing at a rate of 6% each year. Use an exponential function to find the tuition cost after 4 years. So once again, we have our starting amount. A equals $12,000. We have our rate. Rate equals 0.06 to represent 6%. And we have time. This time our time is much smaller, only 4 years. Now that we've got them, let's put them in their places. Y equals 12,000 times 1 plus 0.06 to the 4th. Calculator, 12,000 parentheses 1 plus 0.06 to the 4th. Y equals 15,149.72. Just give me 2 decimal places. All right, let's flip to the back side, do the same thing. Again, up top, A, R, and T are all the same. A is my starting amount. My rate as a decimal. And then T is time. Again, to find decimals from percentages, you just need 2 decimal places. If it's a single digit number, like 4, you'll have 0.04 as your decimal. We'll go through the top 2 and leave the bottom one for you to try out. The population of a town is decreasing at a rate of 1% per year. That decreasing is the key word telling us this is decay, not growth. Increasing, things are getting bigger, that's growth. Decreasing, it's going down, that's decay. In 2000, there were 1,300 people. Use an exponential function to find the population in 2008. So, 1,300 people is my starting amount. My percent rate, 1% per year. As a decimal, 1% is 0.01. And then lastly, we're gonna figure out how long was it? Well, the first year was 2000, and we're trying to figure out by 2008. So we'll just count how many years difference is that. 2001, 2, 3, 4, 5, 6, 7, 8. It's 8 years. We've got our 3 pieces we need. We can set up the equation now. Y equals 1,300, parentheses, 1 minus, remember it's decay, so we're subtracting, 0.01 to the 8th. Calculator, 1,300, parentheses, 1 minus 0.01, close your parentheses, and raise it to the power of 8. You can see our answer, 1,199. That is definitely smaller than we started with, so that is an acceptable answer. If we ended up getting an answer like 2,000, and all of a sudden the number of people in this town was bigger, even though we said it was decreasing, that might be a red flag that we need to double check our math. I wrote 1,199.57. However, we need to fix that because this problem is talking about population and you cannot count 0.57 of a person. So we will just round it up, 1,200 people. Let's do the next one and then leave the third one for you to do. The value of a car is $18,000 and depreciating at a rate of 12% per year. Use an exponential function to find the value of the car after 10 years. So we find our three pieces by saying my starting amount, what's my rate of 12%, depreciating is going down, 0.12, and my time is 10 years. We know our three pieces, let's put them in an equation. Y equals my starting amount, 18,000, parentheses 1 minus my rate, 0.12, and then I need an exponent of 10. I take all of that and I put it into my calculator. 18,000 parentheses 1 minus 0.12, close the parentheses, push the exponent button, and we say 10. After 10 years, that car is worth $5,013.02. That's it. The third one about a farmer buying a tractor is for you to do. Remember to do the third one on the front, and that's all you got to do for exponential growth and decay.